Okay, so in this video we're talking about graphing quadratic functions. And so first thing we need to ask ourselves, what in the world is a quadratic function? Because we've already talked about lines and linear functions. So a quadratic function, all it is it's a function in this form. So y equals ax squared plus bx plus c. Here a, b, and c are just constants. They're just numbers. They could be fraction, decimal, positive, negative. It doesn't really matter. A parabola is the graph of a quadratic function. So it's U-shaped, so it's the graph of a quadratic function. And we know that it's, from previous study, that it's U-shaped. And the two major parts of a parabola are the vertex and its axis of symmetry. Now the vertex, that's always going to be your maximum or your minimum of the parabola. The axis of symmetry is a line. It's really, like I said, it's a line of symmetry, because what happens is, since the parabola is U-shaped, we can essentially just fold the graph over like a mirror effect. So it's like so for every point on the graph on our parabola, it's like buy one get one free because of that symmetry. And what's nice about the axis of symmetry is it always will pass through the vertex, always. So here, remember those coefficients we had? Y equals ax squared plus bx plus c. Well, what we have here is a parabola. So those coefficients mean something. In particular, a means something. So ax squared, that a, if it's positive, means our parabola is going to open up. Notice, like I just said, the axis of symmetry always goes through the vertex. So here, my vertex is the minimum value, or the smallest point on the graph. If in our quadratic function y equals ax squared plus bx plus c, if a is negative, then our parabola is going to open down, and our vertex is going to be the maximum point, or the highest point on our graph. Again, the axis of symmetry always goes through the vertex. Okay, so how do we locate that the vertex of a parabola by hand? Well, it's pretty easy. All you have to do, remember the vertex is an ordered pair. So what we're going to do is first find the x value. So it's negative b over 2a. And remember, that just comes from y equals ax squared plus bx plus c. So I'm going to write that down just so we don't forget it. So we're just using those numbers. A is a number, b is a number. So our x coordinate is that, negative b over 2a. And then the y coordinate, what we would do is, whatever this number turns out to be, we plug it into our quadratic function. So we find the associated y value for this particular x. So all we're going to do is plug in this x value to find the corresponding y value. And that's an ordered pair, so we'll always end up with some x comma y for the vertex. And the equation of line of symmetry is actually easy. It's x equals negative b over 2a. Again, this is a number. Since our parabolas are opening up or opening down, the line of symmetry is always going to be a vertical line, so x equals whatever this number is. Again, the axis of symmetry always passes through the vertex. Pretty easy. Okay, so let's go ahead and do this. So we want to graph this guy by hand. I'm going to cheat a little bit and use a calculator to get some points, but you can do it by hand. But just in the interest of time, I'm going to use a calculator just a little bit. All right, so what we're doing is we're comparing this to y equals ax squared plus bx plus C. So first thing I like to do is just list out what my A, B, and C are. So here, A is 2, B is -8, and then C is 6. All right, so the first thing I want to do is determine, is my parabola going to open up or down? Because when I graph it, if I get something else, then I know automatically I did something wrong. So here, A is positive, so that means my parabola should open up. It should look just like a U. Okay, also I need to go ahead and find my vertex first. All right, so what I'm going to do is I'm going to just define the vertex. I know my x value for the vertex is -b/2a. So I have x equals +8, because negative and negative make a positive, all over 2 times 2, which is 4. So x equals 2 for my vertex. So what I want to do now is take that x equals 2 and plug into my original equation to find the corresponding y value. So everywhere I see an x, I'm going to plug in a 2 to find the corresponding y value for my vertex. So I know 2 squared is 4, so we have 8 minus 2 times 8 is 16 plus 6. Okay, so 8 plus 6 is 14, minus 16 is -2. So when we plug in, we get y equals -2. So what I'm going to do now is just go ahead and graph my vertex. So my vertex is right here. And so that was my scratch work. So now what we can do to get some points is we can actually make a table of values. So x, y, and this is where I'm going to cheat a little bit because I don't want this video to last, a super long time. So I'm just going to get a y equals. We all have access to calculators, so why not? And I'm going to type in my quadratic function, y equals 2x squared minus 8x. Make sure you type this in correctly, because if you don't, obviously you're going to get bad values for your table. Okay, so I'm just going to pick nice values, so I might try 0. And then for 0, I get a corresponding y value of 6. So 0, 6. And what we know is because of symmetry, I buy 1, get 1, 3. So I went over 2 units to the left of the vertex. So I go over 2 units to the right of the vertex. So my corresponding y value is going to be 4, 6. Okay? I want to find at least 5 points here. So let's try to go and find out the x value for x equals 1. So it's 1, 0. And corresponding y value, my symmetry, just fold it over, is 3, 0. Okay, so now I can connect my dots and make a nice U-shaped curve. Something like that. And so I just graphed it by hand. Notice my axis of symmetry. Again, what I use to get my buy 1, get 1, 3 points. So my axis of symmetry always passes through my vertex. My vertex is a minimum for this parabola. Okay? There's actually 3 forms of the quadratic function. Okay, so the first form we talked about was standard form. Okay, so standard form. Now we saw that was y equals ax squared plus bx plus c. The next one we're going to talk about is vertex form. So that's y equals a times quantity x minus h quantity squared plus k. And then the last form we have is called factored form. And that's just simply y equals a times quantity x minus r1 times x minus r2. Okay, so all these things mean something. We're going to talk about those over the next couple of slides, but you definitely need to recognize all 3 forms, know their names, and be able to use them appropriately. Okay, so what is the vertex form? Y equals a times quantity x minus h squared plus k tell us. Well, first off, we know exactly, based on the name, this is vertex form. We know where the vertex lives. So the vertex is located at the ordered pair h comma, k. And we also know A. A stays the same. So if A is positive, that means the parabola opens up. And then if A is negative, then the parabola opens down. Okay? So the vertex form is nice if you're just given the vertex and that's it. Okay? So you need to know that form. Let's go and talk about the factor form. So the factor form, all we're using are the x-intercepts of our parabola. Where does the parabola cross the x-axis? So R1 and R2 are the x-intercepts. Okay, that's very important for you to know. And then again, just like we saw before, so if A is positive, the parabola opens up. And then if A is negative, the parabola opens down. Okay? So the key here is that R1 and R2 are the x-intercepts. And then A still means the same thing. Okay, so let's actually practice with this. So here we want to graph this quadratic function by hand. But the first thing you might want to do is figure out what form is it in. Is it in standard, vertex, or factor form? And this one is actually in vertex form, so I'm just going to write down the general rule. Okay, so I know it's in vertex form. And that's y equals a times x minus h, quantity squared, plus k. Well, now I just want to go through and list off what I know. So here, a is negative 1/2. B is, or sorry, not B, but h, excuse me. So h is negative 3 because negative and negative make a positive. And then k is equal to 4. Okay, well, first thing, a is negative, so what that means is my parabola is actually going to open down for this particular problem. And I also have, I know that my vertex lives at the ordered pair, negative 3, comma 4. So I'm going to go ahead and graph that. So negative 3, comma 4, that's my vertex. And I know my axis of symmetry is a vertical line that goes through my vertex. So this is how I'm going to be able to buy one, get one, 3. So now I might want to do a little bit of scratch work on the side. And what I'm going to do is I'm just going to pick nice values to plug in. Okay? Well, I'm going to cheat again and use my calculator just in the interest of time, but what you would do is you pick a nice value, say x equals 0. Then you would just plug in. Everywhere you see an x, plug in and get the corresponding y value. So I'm going to cheat. I want you to do it by hand, though. It's always good to practice. I'm allowed to cheat because I've had a lot more practice than you've had. So at 0, y is negative 1/2. Okay, but I want to try to find nice values, so let's maybe try 1 instead. So at 1, x equals 1, y is negative 4. So at x equals 1, y is negative 4. Okay, so now I have symmetry. So notice I'm 1, 2, 3, 4 units to the right of the axis of symmetry. So I need to get that corresponding value over here. I need to go 1, 2, 3, 4 units to the left of the axis of symmetry, and I just want to make sure it lines up. Okay, so buy one, get one, 3. Let's try another nice point. Let's try maybe positive or negative 1. So when x equals negative 1, y is positive 2. And again, because of symmetry, I can buy one, get one free, so I have enough points now to make my smooth curve. Okay, so I'm just going to try to connect the dots as nice and as smoothly as I can. Okay, and that's it. That's a sketch of this parabola. Again, it opened down because A was negative. I knew exactly where my vertex was. Pretty easy. We're going to do the same type of idea now, but we got to, again, ask for such. This is standard vertex or factored form. This one actually, this quadratic function is actually in factored form. So, I always like to write down the rule for factored form first. So, we have factored form. And that's y equals a times the quantity x minus r1, x minus r2. And then we just easily list out what we have. So first, a is -1, r1 is equal to -2, because negative and negative make a positive. R2 is 4. Okay? Now remember, R1 and R2 are our x-intercepts. So let's go ahead and plot those. So I have an x-intercept at +4, and I have an x-intercept at -2. Well, notice I don't have any clue about where my vertex lives. Okay? But I need to go ahead and find that somehow, some way. Also notice that A is negative, so we know this parabola is going to open down. Okay? It's going to be an upside down view. Well, what's nice about parabolas is the symmetry, right? Well, since what we can do is fold our parabola on top of each other, so we know the axis of symmetry is going to lie halfway between any two given points. So what I want to do is find the midpoint between these two, and that's going to tell me at least where the axis of symmetry lives. So to get from this point to this point, I have to go 1, 2, 3, 4, 5, 6 total units, so I know the axis of symmetry is the midpoint. So 1, 2, 3. So the axis of symmetry passes through x equals 1. And what's special about the axis of symmetry is I know the vertex lives on it. So since this is x equals 1, I can just plug that in to my equation here, to my function, and get the corresponding y value. Again, in the interest of time, I'm just going to cheat and use my calculator, but you can do this by hand pretty easily. So I'm just typing it in, going to my table. Okay? So I'm just making a table. X and y. And again, I'm testing x equals 1 first because I know my axis, or sorry, my vertex is going to live on that axis of symmetry. So x equals 1, y equals 9. Okay? My vertex lives right here. Alright, so now I just need to find 2 more points. Okay, so maybe at x equals 2, y equals 8. Okay, so at x equals 2, and actually I put my vertex down one spot too low, excuse me. So at x equals 2, y equals 8. Because of symmetry, I buy one, get one free. And now I'm ready to just connect the dots. It's pretty easy at this point. Okay, so just going to connect the dots in a smooth curve that way, and in a smooth curve that way. Kind of missed a little bit, but that's all right. So a parabola looks something like this. Pretty easy. Okay? Now, if a quadratic function is in vertex or factored form, sometimes factored form is called an intercept form because the x-intercepts. How do we write it in standard form? Well, that's easy. All we're going to do is use FOIL or the box to expand out the binomial. So we're going to use FOIL or the box. Okay? Use FOIL or the box, and we're going to simplify. I personally prefer the box. Okay, so I want to take this one at a time. Here I have one in factored form. I want to write it in standard form. So just remember, standard form, let's write it at the top so we don't forget it. Y equals ax squared plus bx plus c. What I want to do first is I'm going to use the box. So I'm just going to rewrite what I have, just so I have some room to work. Okay, you can use FOIL if you prefer. I'm going to do the box. So This negative on the outside, we're going to take care of that last. What I'm doing is I'm just going to multiply these two binomials together first. So x plus 4, x minus 9. Okay, so I end up with x squared, 4x, negative 9x, and then negative 36. Just combine my terms, so I have negative, because I'm taking care of this negative on the outside, times x squared minus 5x minus 36. All right, so now we're going to take care of this negative. We're just going to distribute that negative all the way across. So I end up with y equals negative x squared plus 5x plus 36. And that's in standard form now. No big deal. Okay? Let's draw a line to separate these two. All right, so I want to do the same idea over here. I'm going to take care of my binomial, okay? So that's a binomial squared. So really what we have is x minus 1 times x minus 1. Okay, so I'm just going to rewrite what we have, just so I can get started. Well, again, because I have x minus 1 squared, I can rewrite this guy to help me see it a little bit better. So that's x minus 1 times x minus 1 plus 8. And again, all I want to take care of first is just multiplying the binomial x minus 1 times x minus 1. I'm going to use the box to do that. Then I'll distribute the 3. And then finally at the end, I'll add the 8. Okay? So the name of the game here is baby steps. Don't try to do all this at the same time. So x minus 1, x minus 1. So I have x squared minus x plus 1. So really on the outside here, what I have is 3 times x squared minus 2x plus 1. Then on the outside I have plus 8. Okay? Now I'm going to go ahead and distribute the 3 just like I promised. So we end up with 3x squared minus 6x plus 3. And then this plus 8 is just going to come down. So our final answer, just going to combine my two constants. So y equals 3x squared minus 6x plus 11. Pretty easy, especially if you're comfortable using FOIL or the box. Okay, and that's it for this video. Thank you very much.